Okay, amazing people. We've got some examples here to work through where we've got parallel lines and we need to find the size of the variable or the pronumeral in each case here. So in the first example, we've got an angle of 97 degrees and a pronumeral of A we need to find. Now, first things I want to do is I want to kind of trace over the lines needed to find each of these angles or to identify them. So if I was to do that and go across here and then down and across, it's helping me identify the type of shape that I'm using here. So as we look at this here, this has what appears to be a Z shape. Okay, now thinking about the rules that we use here, when we have that Z type shape, what that means is we have alternate angles. And so we can identify here then that angle A is going to be equal to that 97 degrees. So we can state A equals 97 degrees. And the reason we would state that is if we gave an answer, a reason to it, which we often need to do, is that we have alternate angles on parallel lines. Okay, and that's the reasoning, and that would be all we would have to do in this case. Now in the next example, we've got an angle of 31 degrees and another angle of K degrees. So we need to find the size of that angle K. So again, I want to draw out the angles first. So first of all, the one of 31 appears to be using both two lines here. And the one for K, well, if I go down and then back up here, it's using that line here. Now this one's a little bit hard to see, but as we're looking at it, it's kind of like a twisted and turned around upside down F. And so this one has that F type shape to it here. So it's got that F shape. And so when we have that F shape, what that means is we have, as a result, we have corresponding angles. Okay, so this is what we're using here, that rule of corresponding angles to find the size of K. Now, as a result, we can write K, when we have corresponding angles, they're equal. So K is equal to 31 degrees. And the reason we would write is we have corresponding angles on a parallel line. Or on parallel lines, because there's two of them. And lastly, we get to the last example here. Again, let's think about what shape we have to start off with. So we've got the two parallel lines here. And if I was to trace over the lines that make up those there, I've got that shape here. And you can see that it's kind of giving me that C shape. Okay, and when we have that C shape, what that means is we have co-interior angles. So this one's a little bit more work in order to work it out. But what we're going to have here is we're going to have angle M plus angle 71. They are going to be equal to 180 degrees. And so we're just writing out our working out here in order to calculate it. So in doing so, I want to subtract that 71 degrees from the left-hand side, and I want to move it to the other side of the equation here. And that's going to help me find the value of M that we have here. So as we do that, we have M is equal to 180 minus 71. That's going to give me 109 degrees. And so that's the size of the angle we've got here. And the reason which I have to state is I have to write co-interior angles on parallel lines. And that's how we've found each of the angles in this case.